Today's lesson is 13.1 Experimental and Theoretical Probability. So we're going to learn two things today. First, we're going to learn what experimental probability is and how to find it. And second, we're going to learn what theoretical probability is and how to find that. We're going to start with experimental probability. So they give you this equation, and first I'm going to kind of dissect it a little bit for you. Let me go back real quick. Use my pen. So when you see P and then in parentheses event, what that means is the probability, P stands for probability, of whatever the event is happening, or what's the probability of an event happening. So probability of an event happening. Experimental probability is calculating the probability based off of you doing an actual experiment with it. So that would be the number of times an event occurs over the number of times the experiment is done. Let me erase the ink. Okay, so here's an example. A student chooses a marble from a bag, records the color, and then replaces the marble. After trying the experiment 50 times, he has recorded these results. So he pulled a red marble 23 times, he pulled a blue marble 18 times, and he pulled a green marble 9 times. So 23 red, 18 blue, and 9 green. So find the probability of choosing a blue marble. So the probability of pulling blue will be 18 times out of a total of 50 times. So if you do 18 divided by 50, you're going to get 0.36. So if you convert that into percent, that means he has a 36% chance of pulling a blue marble based off of his actual experiment. Okay, theoretical probability is different. That is the probability of an event happening when you're just thinking in theory. You're not actually doing an experiment. And that equation would be number of, or ratio, would be number of favorable outcomes over the number of possible outcomes. So here would be an example of theoretical probability. What's the chance, what's the probability that you roll a dice and an even number comes up? Well, if you think about it, a dice has 6 sides. It's got 3 odd, 3 even numbers. So you have a 3 in 6 chance of an even number showing up. So that reduced is 1/2, which turned into a decimal is 0.5. And if you convert that into a percent, you have a 50% chance of rolling an even number. Now that's theoretical. If you rolled a dice 3 times, that doesn't necessarily mean half the time or 4 times that you're going to get an even number. But it should end up this way. So theoretical probability is what would happen if you were to perform the event. So here's another example of theoretical probability. Find the probability that the name of a month contains the letter A. So we need a sample space. Think of what the months are. And then favorable outcomes, which ones contain the letter A. So sample space, January through December, there are your 12 months. And then we're going to look through those to see which ones have an A. And it looks like January, February, March, April, May, and August all contain the letter A. So if you think about your theoretical probability, what's the chance of selecting a month that contains the letter A? 6 months out of 12 have an A, so the probability that one of the months contains an A would be 6 out of 12. So you have a 50% chance of selecting a month that has the letter A. This is theoretical, so again, that just means if you were to do this, what most likely should happen? Half the time you should choose a month that has the letter A.